Welcome back to oxidation reduction reactions. In this video, we're going to look at balancing what are called half reactions. So before we do that, we need to go over exactly what oxidation and reduction is. Oxidation is an increase in the oxidation number, and reduction, surprisingly, is a decrease in oxidation number. And the best way to remember this, and I've lost my pen, is what's called Leo and Gur. So you need to remember Leo the lion. That's a really sad looking lion. That doesn't look anything like a lion. Leo the lion says Gur. And that is about the saddest drawing I've ever done in my life. And so Leo means you lose electrons, you're oxidized. Gur means you gain electrons, you are reduced. You are reduced. And it sounds like an easy thing to remember, but sometimes when you're getting into these problems and you're keeping track of everything and you start talking about reducing agents and oxidizing agents, it's sometimes easy to get this mixed up. So you need to remember this. Leo says Gur. Alright, I just paused this for about 40 minutes, so I don't really remember what I was saying right before this, but let me pick up. So, when you look at this equation here, let's figure out what we have for the oxidation numbers for all these. So hydrogen is plus 1, so chloride is negative 1. We have oxygen is negative 2. Hydrogen is plus 1. We have 3 oxygen, so that's negative 6. So nitrogen has to be plus 5. Over here we have negative 2 for oxygen, so hydrogen is plus 4. Chlorine is 0 right here because it's the element. Oxygen is negative 2. Hydrogen is plus 1. So when we look at this, we have nitrogen is going from plus 5 to plus 4. So it's losing electrons, so it is being oxidized. And then when we have chlorine, oh wait, sorry, it's gaining electrons, so it is being reduced. And then we have chlorine is going from negative 1 to 0. So it is losing electrons, so it is being oxidized. So this is what oxidation numbers allow you to do. They allow you to tell what in the reaction is being oxidized and what is being reduced. Now, in order to balance a redox reaction, you have to balance two half equations. You have one for oxidation. And so really the first couple steps you do is you just make sure you have the same amount of, in this case for instance, irons on both sides. So we have one iron here, one iron here. And then what we have to do is we have to balance the charge. And we balance the charges by adding electrons. So we have plus 2 over here, we have plus 3 over here. So we need those charges to be equal. So we add an electron. So now this side is plus 2, this side is plus 2, and the charges are balanced. Here's an example for chlorine, where chlorine is going from an oxidation number of 0 to negative 1. So once again, we need to balance the mass, so we look 2 chlorines on this side, so we've got to get 2 chlorines on the reactant side, and then so this side is negative 2, this side is 0, so we've got to add 2 electrons to this side of the equation. So we end up with chlorine plus 2 electrons produces 2 chlorides. Alright? Now, and I think, oh, I kind of messed that up, sorry. So this is the same thing in a much easier way to look at. This is how we balance going from chlorine to chloride. Alright, these are the rules for balancing the half equations for redox reactions. And we're going to go over, if you'll keep an eye on these rules and look at them as we go through balancing a half equation. So let's do that now. So we're going to take permanganate here, produces manganese plus 2. And this is in an acidic solution. So let's do this right now. The first thing that we do is we need to make sure that we balance the manganese. So we have one manganese on this side, and we have one manganese on the product side. Should have picked an easier element to pronounce. The next thing we need to do is to balance the oxidation number by adding electrons. Alright, so let's look at this. So if I rewrite this down here, we have oxygen is -2, so we have 4 of those, so that's -8. So manganese needs to be +7, and it's going to manganese with a +2. So it's +7 over here, +2 over here, so we need to balance the oxidation numbers with electrons. So to go from +7 to +2, we have to add 5 electrons to the reactant side. Alright, so we balance the manganese, we balance the oxidation numbers. Now we need to balance the charge. So let me rewrite this again a little cleaner. So we have 5 electrons plus MnO4 negative produces Mn plus 2. Alright, so on the reactant side here, we have a total charge of -6, -5 here, -1 here, so that's -6, and then the manganese is +2. So we need to balance this by adding, because this is an acidic solution, we're going to add hydrogen ions. So hydrogens are positive. So we're going to take this side from -6 to +2. So that's going to take 8 hydrogen ions. Alright, so let me get my pen back. So I balance the charge by adding hydrogen, I missed there. Balance the charge by adding hydrogen ions. And now I'm going to balance the hydrogen by adding water molecules. So we have 8 hydrogens on this side. So we need 4 waters on this side, because 4 times H2 is 8 hydrogens. We have 8 hydrogens on this side. And then we need to make sure that oxygen is balanced. So 4 oxygens on this side, 4 times 1 oxygen here is 4 oxygens on this side. So I now have my balanced half equation. So let me write this nice and neat. So 8 hydrogens plus 5 electrons plus the permanganate yields manganese 2 plus 4 waters. Sorry for my lame writing there. So look, this is going to take some practice, and you're going to have to follow these steps as you do it. A couple times after doing this, you'll get it. And you could also just try this one again, since we have the explanation right here. So let's look at another example. Alright, so here we have chromium hydroxide produces chromate. Alright, so the first thing we need to do is we need to figure out the oxidation numbers in this. Alright, so oxygen is, actually, since chromate is an ion, we know it's +3, so chromate is +3. because hydroxide is -1. Over here, we know that oxygen is -2. So that's a total of -8, and it equals -2. So this chromate must be +6. So it is losing electrons because it's becoming more positive. So chromate is being oxidized. So the first thing we need to do is we need to balance the chromate. There's one chromate on our reactant side, one chromate on our product side, so that is balanced. The next thing we need to do is we need to balance the oxidation numbers. Oops, I don't know what's going on here, sorry. Balance the oxidation numbers by adding electrons. So we're going from +3 to +6. So we need to bring this side down to +3. So we are going to add 3 electrons to this side. And that's going to balance the oxidation number. So both sides have an oxidation number of +3. The next thing we're going to do is, because this is in a basic solution, we're going to balance the charge by adding hydroxide ions. So this side has a total charge of -5, and our chromium hydroxide side has a total charge of 0. So hydroxide has a negative charge, so we're going to add 5 hydroxides to the product side, and that's going to bring this side to -5. So both sides are -5. Now, the next thing we need to do is we need to balance hydrogen by adding waters. So we have, and we need to be careful here, we have 5 hydrogens in the hydroxide. We have 3 hydrogens in the chromium hydroxide, so we have a total of 8 hydrogens on the reactant side. So to get 8 hydrogens, we're going to need to add 4 waters. So that's going to balance our hydrogens, and then we need to make sure that oxygen is balanced. So we have 5 oxygens here plus 3 here, so we have 8 oxygens on the reactant side. We have 4 oxygens here plus 4 oxygens here. We have 8 oxygens on this side. So this is our final balanced half equation. And if you do this right, you're going to end up with the hydrogens being balanced. If you did something wrong, and I don't know, I'm having so much trouble writing. If you did something wrong, then the oxygens aren't going to end up balanced. So here is our final equation: plus 3 electrons plus 4 waters. Alright? And that's not much neater than what I ended up with in the first place. So these are the steps to balancing half reactions. You have to know whether it's an acidic or basic solution, and this takes some practice to learn how to do it. And I'll try to put some more practice problems up here.